Hi everyone, we're back in chapter 7, electricity and electrical safety. And in this section 7-5, we're going to discuss light energy. So electromagnetic spectrum, that's also known as electromagnetic spectrum of radiation. And it's the name given to all forms of energy or radiation that exists. Now the forms of energy in the electromagnetic spectrum are, here we can see radio waves, and that's, here you see the radio and television. And then here's your cell phone. And then microwave waves from your microwave oven. And then there's the light rays, which is, here we have infrared, visible, and ultraviolet. And then beyond that are the X-rays, and then beyond that is the gamma rays, which are used in nuclear power plants. So did you know that although the electric lighting in your spa, salon, or barbershop, it's not really a form of light therapy? It is the quality of light this quality of light can really have an effect on your work and your client's satisfaction. So think about fluorescent lights. Fluorescent lighting, that's produced by those fluorescent light bulbs. And it can be cooler. It's more of a blue-green than natural sunlight. And so incandescent lighting, that's produced by the standard tungsten light bulbs. And it is warmer yellow gold than natural sunlight or fluorescent light. Now your client's hair, skin, and nails will appear more green-blue when viewed with fluorescent lighting and more golden when viewed with incandescent light. But you want to be careful when you're handling fluorescent light bulbs because they do contain dangerous substances, including mercury. So avoid breaking the fluorescent bulbs and dispose of them, the used ones, properly. So energy moves through space in waves, and these waves are similar to the waves caused when you drop a stone on water and you see the rippling effect or the waves. Now each type of energy has its own wavelength, and you can see here the wavelengths. So let's talk about that. So we have waveform patterns. There's the long wavelength and the short. Okay, so here's the definition for wavelength. Okay, a wavelength is the distance between successive peaks of electromagnetic waves. So I drew that here for you. This is from this peak to this peak, that peak to that peak. Now a waveform, okay, this is the measurement between those two peaks. That's waveform. Okay, so some wavelengths are long and some are short. The long ones have low energy, like this, really low energy. Okay, and meaning that the number of waves is less frequent. You have fewer waves than you do with short. So short wavelengths, that has high energy. Here you can see high energy, high frequency. So because the number of waves is really short, okay, and you can see that in that pattern. So let's take a look at the difference here of those two. So here we have our long wavelengths, and let me get this right. So we have low frequency, deeper penetration, less energy. Short wavelengths have high frequency, less penetration, and more energy. Okay, so we're going to talk about visible light. And visible light is the part of the electromagnetic spectrum that you can see, hence the name visible, right? So the visible spectrum of the light makes up only 35% of our natural sunlight. So here we can see, whoops, yeah, that's right, sorry. Here we can see the visible light right here, okay? And so the visible light from the violet, this has the short wavelengths, the shortest, and from the red light, this one has the long wavelengths. Okay, so natural sunlight, it is made up of 3 different types of light. And so here we have the visible light, again, making up 35% of our UV rays. And then invisible light makes up 60% of the rays. And invisible ultraviolet, I should say invisible, let me go back. Invisible infrared, that makes up 60%. And then invisible ultraviolet makes up 5%. But when you total them, invisible light is 65% of the natural sunlight. Okay, so now we're going to talk about invisible light. And invisible light is this. It's on either end. Here's the visible, and it's on either side of it. This is invisible, ultraviolet, and then infrared. Okay, so these, you cannot see these. They're not visible to the naked eye. Now, before the visible violet light, hence the name ultraviolet, okay, is there by the violet side. And on the red side here is the infrared. So that's how they got their names. Now, if light is passed through a prism, then like a glass prism, then you'll notice the like a rainbow. So I'm going to show you here. So here light comes through a glass or plastic prism, and then you'll see the 7 different colors of the rainbow. Okay, and it's always in the same order. So here we have violet, the shortest wavelength, and then indigo and blue, and then green, yellow, orange, and red. Red's the longest wavelength. Okay, these colors are visible to the eye. And then ultraviolet, as we were looking, ultraviolet here. Okay, so here's ultraviolet again. This is abbreviated as UV light, and it's also known as cold or actinic light, and it is invisible light, and it has a short wavelength, see, and giving it, these are shorter than over here, giving it a lot more energy, okay? It is less penetrating than visible light, and it does cause chemical reactions to happen more quickly than visible light, and it does produce, visible light produces less heat, or well, ultraviolet produces less heat than visible, and it does kill some germs. Now, UV light promotes your skin to create vitamin D. Remember this? We were learning about how the sun comes in, mixes in with the cholesterol, and then starts the process of making vitamin D. And vitamin D is a fat-soluble vitamin, and it's really good for our bone growth and our health. Well, we all need sunlight in order to survive. And then, because if we didn't have that, I mean, life wouldn't exist. So we have to have sunlight. But overexposure to that can cause premature aging and even skin cancer. So we remember learning about how here is your collagen and your elastin, and here these green dots are your hyaluronic acid. And when the sun comes in to the skin, it breaks the collagen. Look at the hyaluronic acid. They're smaller and you have very few. And then the elastin is broken as well. So, and then again, those UV light is causing, we know, is a carcinogen, so it does cause cancers. Okay, skin cancer. And did you know the incidence of skin cancer has reached a near epidemic level? There's over 1 million new cases being diagnosed every year, and it's estimated that 1 out of 5 Americans will develop skin cancer, and 90% of those cancers are the result of exposure to ultraviolet radiation from natural sunlight, sun lamps, and tanning beds. Now we're going to talk about the three types of UV light. There's the ultraviolet A, ultraviolet B, and the ultraviolet C. Okay, so the ultraviolet A is the longest wavelength of the UV light spectrum, and it goes directly into the dermis. And remember, we were learning that the dermis is where collagen and elastin, hyaluronic acid, ground substance, capillaries, blood vessels, that all lives there. So the UV A for aging, damages those substances in the dermis. And UVA light is the light most often used in tanning beds. Now the UVB, again, burning rays, these ones right here, they're most associated with sunburns. And you guys remember, they only go to the lower epidermis. Okay, so excessive use of both A and B light, it can cause skin cancers. Now, UVC is blocked by our ozone layer. We've seen that before. Okay, so if this light here, if it got to Earth, it would completely kill all plant and animal life. So UVC, though, is effective at killing bacteria, viruses, mold, and pathogens. Now, the application of UV light, it can be beneficial, but it can be done with the utmost care and proper manner by a qualified professional. But overexposure can lead to skin damage and skin cancer. Now, UV light has also been used to kill bacteria on the skin, help produce our vitamin D, and it is used in the weaker form to cure UV gel nails. Dermatologists, they use UV therapy in addition to drugs to treatment for psoriasis. They'll use a drug called Psoralen, and you put the Psoralen on the skin, and then you go lay in a tanning bed, and what it does is it interacts with the UV light, the Psoralen, and it goes to the DNA of the cells, and it stops the overproliferation. So it's a treatment that they do use for that. Now, infrared light, that's the one that has the longest wavelengths right here, long wavelengths, and it penetrates more deeply, does have low frequency, and it does make up 60% of our natural sunlight. And infrared lamps, those are used mainly during hair conditioning treatments and to process hair coloring. And they're also used in salon and spas for relaxation and warming up muscles. Now, infrared light has also been used to diminish signs of aging, such as rhytids, to heal wounds, and to increase circulation. And so, did you know we need to strike a balance, a delicate balance between with sunlight exposure and that, keeping in mind, guys, that tan skin is actually damaged skin. Tanning will eventually cause photoaging, premature aging due to sun exposure, and irreversible damage to your skin's collagen building properties. So, light into chemical energy. So a catalyst right here, catalysts are substances that speed up a chemical reaction. Now, some catalysts use heat as their energy source, while others use light. Whatever the energy source is, whether it's heat or light, catalysts, what they do is they absorb energy like a battery. At the appropriate time, they pass this energy to the initiator and a reaction begins. Now, other chemicals, a catalyst will not get consumed in the chemical reaction. For example, in hair coloring services, hydrogen peroxide, the developer, that's the catalyst, and it allows your hair color to penetrate the cortex of the hair, creating a permanent color. Now in acrylic nails, the monomers used are the catalysts to solidify the nails, and in the application of gel nails. And the UV light is the catalyst for the hardening. Okay, so we're going to talk about light therapy. Now, light therapy is also known as phototherapy. Remember, photo means light. And it is the application of light rays to the skin for the treatment of rhytids, capillaries, or pigmentation, or even hair removal. So lasers, I'll show you here. Lasers and light therapy devices, they've been used for years. And some of those original techniques are still valid today. Lasers are designed to focus all the light power to a specific depth so they can adjust the depth of that light power and in one direction within the skin using the same color of light. Now in contrast, other light therapies, they have multiple depths, colors, and wavelengths, and the light may be scattered. Now the most important point to remember about light therapy is that the equipment you use is selected based on the skin type and the condition that you're treating. Okay, so this concludes 7-5. There is a check-in question that you need to answer, and then send that to me at krista@oliverfinley.com. And then, so after you complete that, then I want you to go to the read section of this chapter and go ahead and read the discuss light energy again. And then there's a do section. It's ultraviolet light matching, so you'll go through that. And then chapter 7 also has another folder that has a do, and it's called light energy multiple choice. So you'll do that. And then once you complete all this, then you're going to go into the folder that says chapter review, and you'll go ahead and open it up. It'll say chapter 7 due, and you'll go ahead and take your final chapter exam. So that is it on electricity, and everybody, good luck. See you.